I'm Xavier Demoulin-Radijeux. I'm a senior staff scientist in the R&D Transfections department. We working on developing new product, transfection products, some including Invivofectamine 2.0 and Invivofectamine RNA Max. The new invention that we recently launched is related to the transfections. More specifically, we're trying to give tools for researchers to allow them to deliver nucleic acid in small animal models. What we found in the past, a lot of people use our transfection reagents like Invivofectamine 2.0 and RNA Max, mostly in vitro, in cell lines, but we see the field moving toward more physiologically relevant models. People want to now deliver primary cells, such as neurons, B cells, T cells, and ultimately they really want to study the gene functions in vivo, so it's small animal models such as mouse and rats, and of course then may lead to therapeutics. So in the past there was really no tools out there to allow them to deliver siRNA or nucleic acid directly in vivo, mostly because as soon as you put in animal models, the blood nucleases will degrade the nucleic acid and nothing would happen. So we developed this product that is liposome based that basically kind of protect your nucleic acid from the degradation from the serum and the blood, and then allow you to deliver siRNA, for example, in specific organs. And so the first one that we developed is called Invivofectamine 2, is mostly designed to deliver siRNA very efficiently in the liver. And what we found is you can deliver almost in 90% of the hepatocytes and silence the gene more than 90% for many weeks. So in terms of applications, basically, because you can now do this, you can imagine you could do knockout animals very quickly. Like with siRNA, you could simply go in front of your computer and you say, you know, I want to knock out these genes, I'm going to design an siRNA. In a week you have your siRNA, it's going to be very potent. You simply complex with our reagent, which is very easy to use, and then you can knock out a gene the next day and study the function. So it's a really powerful tool, and you could do all this in very limited time, versus if you do the traditional way, such as the transgenic or knockout models, then it will take months. You have to do the cloning and then prepare the progeny and then breed the mice and for the same result. So what we see now is a growing interest to do this directly in vivo instead of cell lines and rapidly assess the function of the genes. And so you could also do multiple genes at the same time, which would be very difficult to do with knockout animals. So actually there's nothing out there yet. We think some more product like this will come out, but at this point there's really nothing out there. It's really the first product of its generations that allow you to do this with a very efficient manner. There are things out there developed by the big pharma that they use this similar technology for developing therapeutics for human disease, but in the research market there's really no tool like this, which is really easy to use and very efficient.